Hey everybody, welcome back to lesson 4 on tables of relative strength and spontaneity rule. Hope you're all doing well. I tell you, those videos I was putting in that music got a little crazy. One of my videos on YouTube had over 10 views, so I'm going to have to tone that down a little bit. Things are getting bacterial out there. I don't want to go viral or anything, so no video today. I'm going to do a quick little review how to use the half reaction method to balance a redox equation. So I've already done this, so you can just sit back and relax. And we will be working on page 196 in our guide. Oh, here we go in real time. Okay, so Mn2 plus goes to MnO4 minus. So I need 4 oxygens. That's 4 waters. Okay, 4 oxygens, 8 hydrogens, 8 hydrogens. Okay, charges are always a little tricky. So on the left, I have 2 plus. On the right, 1 minus and 8 plus. So 7 plus, 2 plus. I got to get them equal. You always add the electrons to the more positive. So I'm adding 5 electrons. 5 negatives gives me 2 plus. And we are balanced. 5 electrons. So there's my balanced half reaction. This one is losing electrons, so this would be Mn2 plus would be the reducing agent losing electrons undergoing oxidation. HbIO3 goes to Bi3 plus. Oh man, I'm in rough shape today. This is like 9 hours of working on the computer. My body is trashed. I am not used to sitting still for so long and then staring at a screen. I got a headache. My chest hurts. Ugh, brutal. Anyway. All right. So 1 bismuth, 1 bismuth, 3 oxygen, 3 oxygen, my waters, 6 hydrogen. I've already got 1 hydrogen, so I need 5 more. Okay, 5 aqueous hydrogen ions. Throw my states in there. Okay, charges. So I have 3 plus on the right, 5 plus on the left, so I need to add 2 electrons to get to 3 plus. 2 electrons. Okay, there's my other balanced half reaction. Now I'm going to add them together to get my net reaction. And before I do that, I got to balance my electrons. 5 lost, 2 gained. Common multiple would be 10, so I'm going to times everything in the top one by 2 and everything in the bottom by 5. So to simplify things, I'm just going to go straight through the equation and change everything. 8H2O, 2 of those, 16, and 10 electrons. Okay, bottom one, 5 times 2 is 10 electrons. Those cancel out. Electrons gained equal electrons lost. Okay, this is crazy. 25 H plus, 5 of those, and 15 waters. Okay. Now, Casey pointed out in my last video, I think it was my last one or second last one, I forgot to carry the waters down when I wrote out the half reactions and balanced it. I just totally ignored the waters, and that was an error on my part. You have to include the waters. Okay, so here we go. I've got 8 waters, 2 Mn2 plus, 25 H plus. I'll simplify those later. 5 HbIO3. I'm going to run out of room, so I'm going to put it here, and that becomes 2 MnO4 minus. Boy, those are messy. And 16 H plus. 5 Bi3 plus. And 15 H2Os. Okay, let's simplify. We're going to take 8 waters away from each side. 8 gone, 8 gone, which leaves me with 7 waters. 16 hydrogen, 25, so I can take away 16 from both. 25 becomes 9. Okay, there's your balanced redox reaction using the half reaction method. That's about as tricky as they get. Okay, second thing you guys learned how to do is build tables of relative strength. So first thing you need to do is identify your oxidizing agents. Is it the column or the row? You look for the more positive set because those are the ones that gain electrons, and that would be these guys. Copper 2 plus is more positive than copper. Se is more positive than Se2 minus. Okay, so from our oxidizing agents, we're going to list them from strongest to weakest. So 1, 2, 3, bromine undergoes 3 reactions. That is the strongest. It turns into Br minus, 2 of those, 2 of those, 2 electrons to balance. Okay, there's our first half reaction. Bromine is done. Next strongest is Ag plus, has 2 reactions. Ag plus gains 1 electron to become Ag solid. And next one would be copper with 1 reaction. Copper 2 plus gains 2 electrons to become copper solid. And selenium has no reactions. It is the weakest oxidizing agent, and that turns into Se2 minus, gains 2 electrons, Se2 minus. Okay, I'm not going to put states in. I'm just ripping through this one fast. Strongest oxidizing agent going down to weakest. Strongest reducing agent going up to weakest. The strongest oxidizing agent always has the weakest reducing agent as its partner in the half reaction. All right, moving on to today's lesson. Hopefully that review was worthwhile for you. So again, in our notes, page 196 in your study guide. Okay, as a rule, metal atoms are reducing agents. Metals are losers. They will easily lose their loosely held valence electrons. Most cations are oxidizing agents. They're positive. They will attract or gain electrons. But the multivalent metal ions can lose electrons and become more positive, or gain electrons and become neutral. So you got to watch out for those. They're sort of like double agents. They will both gain and lose electrons. Okay, so categorize the following as oxidizing agents, reducing agents, or both. Au3 plus is very positive. That will be an oxidizing agent. Let's do its partner right now, Au. How do you get from Au3 plus to Au? Gain 3 electrons. So there's our half reaction with our oxidizing agent and its reducing agent partner. Okay. What else have we got? Nickel 3 plus. Okay, nickel 3 plus would be the oxidizing agent. And there's nickel solid. And that's the only other nickel in there. So that one would gain 3 electrons to go to nickel solid. Again, I'm going to skip states just to fly through this. Oh, and I'm not putting these in order of strength, right? We have no way of predicting that. I'm just listing all the half reactions. Okay, let's go with, here's tin 4 plus. There's a very positive oxidizing agent. And you will notice that tin 4 plus, there's a tin 2 plus and a tin. So what are we going to do about that? Tin 4 plus will gain 2 electrons and become tin 2 plus. Now, tin 2 plus, I'm going to circle it and star it and draw a rainbow and a unicorn. Yes, there it is, world premiere. Swooshy tail, I need some colors. Unicorns have a nice pink horn. Smile, let's put some colors in there. You're thinking, what's happened? He's losing it. 9 hours of planning and lessons, and Johnson is lost. Okay, so tin 2 plus is both a reducing agent and an oxidizing agent. It's one of those multivalent metals that can both lose electrons going this way, put it in red, lose electrons as a reducing agent, gain electrons as an oxidizing agent. So when you have multivalent metals, it's always the lower charge that is both. Tin 2 plus is the lower charge from tin 2 plus and tin 4 plus. Okay, so that one's gone, that one's gone, that one's gone. If you want to try and do the rest of them, you can pause the video and fill in the rest and then come back and see how you did. Okay, so I've got iron 2 plus and iron. So iron 2 plus would be my oxidizing agent, gaining 2 electrons to become iron. That one's gone. Okay, sulfur and sulfur 2 minus. Which one's more positive? Sulfur gains 2 electrons to become sulfur 2 minus. So all we're doing here is just practicing recognizing oxidizing and reducing agents given the pairs. O2 is more positive, gains 2 electrons to become O2 minus, and if I was going to balance that one, I would need a 2 in front of it, which means 4 electrons. Each oxygen gains 2. Or I could write half of an O2 minus. Okay, what's left? Nickel and chlorine, and nickel is, I just forgot to cross that out, I guess. Nickel 3 plus and nickel, yep. Okay, Cl minus and Cl2. Which one's more positive? Cl2 gains 2 electrons to become 2 chlorides. Okay, so we made all these half reactions, but it's not in order. Okay, we just know those are the potential half reactions. Yes, we noticed. Of course we did. Okay, beware of the multivalent metals that can gain or lose. So we talked about these. So here is Fe2 plus as a reducing agent and an oxidizing agent. Gains 1 electron, and here it gains 2 electrons. Okay, identify 3 more multivalent ions and include them in this table. So jump to your periodic table. You can pause, find a few multivalents and put them in the table. Then come back and I'll have a couple more examples for you as well. Okay, so I am going to go with, let's go chromium 3. No, let's do something different. Let's go with ruthenium 4 plus and 3 plus. So Ru4 plus is the most positive, and it goes to Ru3 plus. Are you kidding? No, I'm not. Okay, there we go. And then Ru3 plus can gain 3 and become Ru. So there's our double agent, both oxidizing and reducing agent. Trying to find something on here that's quite unique. Niobium 5 plus 3 plus. So niobium 5 plus will drop down to niobium 3 plus. And then the 3 plus can drop down to 0, or its element, 3 electrons. Okay, so there's some half reactions for the multivalent. If you had these two charges, which one would be the strongest oxidizing agent? 3 plus, and the same with this pairing, the 4 plus. So the higher the charge, the stronger the oxidizing agent when you're comparing the same ions. Okay, any questions? You probably do, but I can't hear you. Oh, I'm just so funny tonight. Sleep deprivation and chronic screen time is just toasting me. Okay. Spontaneity of redox reactions. So here's the big topic for today. So this was kind of like a small topic. You do need to know this stuff, but here's what we're really going to focus on is using the spontaneity rule. What does that mean? Basically, it means that you can predict whether or not a reaction will be spontaneous. Will it happen? And you can do that using the table of relative strengths. And the rule is very simple. So if we have this table of relative strengths with oxidizing agents on the left and reducing agents on the right, if the oxidizing agent sits above the reducing agent, then we say it's a spontaneous reaction and it goes forward. So oxidizing agent above reducing agent. If the oxidizing agent sits below the reducing agent on the table, then it is non-spontaneous, which means no reaction. So here's our table of relative strengths that we built last class. Table of relative strengths. Oh my gosh. Okay. So make a prediction using the spontaneity rule. Will the following react? Ag plus and copper. So there's Ag plus and there's copper. So using the spontaneity rule, which of these two scenarios applies? Here's our oxidizing agents, reducing agents, and our oxidizing agent sits above the reducing agent. So we say spontaneous. In other words, it will move forward and react. Okay, copper 2 plus and lead. Copper 2 plus and lead. Okay, is this one spontaneous? You are correct, Evan. Yes, the copper 2 plus sits above the lead. Spontaneous. Okay. Zinc 2 plus and copper. Zinc 2 plus and copper. Is this one spontaneous, Maddie? And you are also correct. It is not. The oxidizing agent sits below the reducing agent. So we would say non-spontaneous. Okay, last one. Copper 2 plus, copper 2 plus, and copper. Straight across. Straight across means non-spontaneous. Metals don't react with their own ions. The only way you get spontaneous is if the oxidizing agent is above. So reducing agent, we could put this as well. Straight across is no-go. It's not a spontaneous reaction. Now it says in red, this is a small version of your data book. What? There's a table of relative strengths in your data book? You didn't tell us that. Okay, so I want you to pause the video, grab your data book, and flip to page number 7. Get ready to be shocked. Page 7. Okay, so on page 7, we have a huge table of relative strengths that you will have access to for the entire redox unit. You can look up half reactions in here. You can make predictions. Our strongest oxidizing agent on the entire table is fluorine. It reacts with every reducing agent because they're all below it. And our weakest oxidizing agent, way down at the bottom, is lithium plus. It reacts with nothing. However, its metal, lithium solid, is crazy reactive. It's the strongest reducing agent. And that means the weakest reducing agent of them all is the 2 fluoride ions, 2F minus. So you can make all these predictions. Will fluorine react with gold? Yes, it will. Will iodine react with gold? No, it won't. So using that big table, I should have popped one up on here. You can make all kinds of predictions as to whether or not a reaction will happen. And we'll be doing that in 1 or 2 lessons from now. Okay, now that was big key idea number 1. So big idea. That's a brain or a really swollen fist. Okay, so big idea, spontaneity rule. Okay, second big idea. How can I draw a big idea? Oh yes, I could do this. I think I've shown you that before. What is that? I know you're going to say it's a light bulb. No, it's not. It is some guy bent over pulling up his pants. Oh, disgusting. Okay, so second big idea. You need to be able to take data on just a few reactions and build a table of relative strengths. Now, this is very different than how we started today when you were given a whole bunch of data. You were given the data for 16 reactions, which makes it easy to build a table of relative strengths. What about when you're only given the data from 3 reactions? You can do it as well. It's a different method to do it. Here's how it works. So we know that an oxidizing agent that sits above a reducing agent gives us spontaneous. If the oxidizing agent sits below the reducing agent, non-spontaneous. So we use that rule to figure out how to build these tables, and it's pretty simple. In this reaction, could you identify which of these is the oxidizing agent and which is the reducing agent? It's always going to be the more positive, right? And we can see cobalt 2 plus becomes cobalt. So this one's more positive, so this is the oxidizing agent. Indium becomes indium 3 plus, so that means this is the reducing agent. Every redox reaction has both. All right, so this reaction is spontaneous. What does that tell us about where cobalt 2 plus sits relative to indium? It means that cobalt 2 plus sits above indium in our table of relative strengths. Okay, it makes sense because it's a spontaneous reaction. So the cobalt 2 plus has to sit above the indium reducing agent. So I've already figured out the order of 2 of them in the table. Okay, next one, copper 2 plus, and there's its partner. So this is the oxidizing agent. Cobalt is the reducing agent. This one is also spontaneous. So copper 2 plus sits above cobalt solid. So cobalt solid would be here because this is the half reaction. Copper 2 plus has to be above cobalt, so it sits right here. Copper 2 plus, and its metal would be straight across. So there's its half reaction. I did not plan that spacing out very well. Okay, copper 2 plus does not react with palladium. So that means that the copper 2 plus must sit below the palladium, because remember, this is our oxidizing agent, this is our reducing agent. Copper 2 plus sits below palladium. I have to rebuild this. Okay, copper 2 plus 2 electrons goes to copper. Copper 2 plus sits below palladium, so that means palladium is up there, which means its other partner, the oxidizing agent, is straight across from it. And we already decided that cobalt 2 plus is below, like that. So let's just test the data and see if this table works. So I'm going to switch colors. Cobalt 2 plus reacts with indium. Oh, I forgot about indium. Okay, indium's right there. Good thing we checked our table. And that was indium 3 plus, which means 3 electrons. Okay, let's try that again. Cobalt 2 plus reacts with indium. Cobalt 2 plus reacts with indium. Yes, that one is spontaneous downhill. Okay, copper 2 plus reacts with cobalt. Copper 2 plus reacts with cobalt. Yes, that one is also downhill. That works. Okay, copper 2 plus does not react with palladium. Copper 2 plus does not react with palladium. That one is uphill. Good, the table works. Okay, that's how you build a table of relative strengths using just a few reactions. Okay, we're going to do a few of these. Okay, and we'll get faster and faster as we go. Construct a table of relative strengths. Cobalt 2 plus and zinc. Who's the oxidizing agent? Okay, so cobalt 2 plus sits above zinc, reducing agent, because it reacts spontaneous. So I'm just going to put this in the middle this time. I'm going to be a little smarter. Cobalt sits above zinc. So I can write cobalt solid, gains 2 electrons. I can do zinc's half reaction, zinc 2 plus, gains 2 electrons, and I've left space here in case I need to sneak one in between. Magnesium 2 plus does not react with zinc solid. So there's zinc. Where does magnesium 2 plus go as the oxidizing agent? It has to go below zinc, so it sits here. There's its half reaction. So magnesium 2 plus does not react with zinc, it's uphill, but cobalt 2 plus does react with zinc, it's downhill, or the oxidizing agent is above the reducing agent, and for this one it is the oxidizing agent is below. So this one works. That was a nice simple one. Just to speed these up, I'm going to skip states just to build the patterns, and there's our strongest oxidizing agent, weakest. So would magnesium 2 plus react with cobalt? Mg2 plus with cobalt? No, non-spontaneous. So once you built the table, you can also make predictions. Okay, back into your study guide. All right, build a table of relative strengths using the above data. So we're just going to start right into this. Here's our oxidizing agents. They're the more positive. And here's our reducing agents. Okay, so A2 plus as an oxidizing agent. A2 plus becomes A. So I'm just going to write this one out. 2 electrons becomes A. Okay, so what do we know about A2 plus? It reacts with D. So A2 plus reacts with D, which means D is below it. So I'm just going to put it there and leave space to write on both side, both above and below it. And that's D. These are all 2 plus. D2 plus. It's starting to look like my middle school report card. An A and a D. Okay. B. What are we doing with B2 plus? So it does not react with A. B2 plus does not react with A. This is a bit of a problem. It could be here or here. I honestly don't know. All I know is that B2 plus is below A. So I'm just going to leave it for now. C2 plus reacts with A. C2 plus reacts with A. So where are we putting C2 plus? Above. And I'm going to leave room in case I need to squeeze one in there. C2 plus 2 electrons goes to C. Okay, so A and C are done. What about D? D2 plus does not react with B. D2, oh, there's D2 plus, and it does not react with B. So that means B is sitting here. So that means this one was correct and this one was wrong. B2 plus goes to B. So strongest oxidizing agent is C2 plus. Weakest is D2 plus, but it's got the strongest reducing agent and the weakest. So we can just double check our reactions. A2 plus reacts with D. A2 plus, yes, it reacts with D. D is below it. B2 plus does not react with A. I'll switch colors. B2 plus does not react with A. Uphill, C2 plus reacts with A. C2 plus reacts with A, yes. And D2 plus does not react with B. D2 plus does not react with B, uphill. Okay, they all work. Whoops, that's got to be a little happier. Let's go demure. That's my demure. Or maybe bashful. Sure. Okay. All right, 4 nonmetal oxidizing agents. So there's our nonmetal oxidizing agents. And here are their ions, which will be the reducing agents. So they've helped us out there. Okay, X2 as an oxidizing agent reacts with W minus and Y. So X2 sits above W minus and Y. I don't know which of those is stronger, so I'm just going to put them side by side. Oh, only. That means that it does not react with Z minus. It reacts with W and Y, but not with Z. So that means Z minus is sitting up there. Okay, so I can finish this one off. Z2 plus 2 electrons makes 2 Z minuses. X2 plus 2 electrons makes 2 X minuses. Now I just got to figure these two out. Y will reduce W2. So Y reacts with W2. So that means Y, this is a bit of a problem. No, it's not. That should be Y minus. That's all. That's probably hidden under my eraser. Yes, it is. Okay, Y minus will react with W2. So that means Y minus must be below W2. And I don't know why I made that X squared, X2. So Y minus has to sit down here because it reacts with W2. And Y2 plus 2 electrons gives 2Y minus. Okay, let's just do a quick check. X2 reacts with W minus and Y minus. So X2 reacts with W minus and Y minus. Yes, only. X2 does not react with Z minus. And Y minus reacts with W2. Yes. Okay, that's jubilant, in case you were wondering. Jubilant. And I feel like, yeah, last one. Hang in there, last one. Okay. If you are feeling confident, you can do this one on your own and then come back and check to see how you did. So if you want to pause the video right now, give it a try, and then see how you did. Okay, there's the metals. There's our reducing agents. Our oxidizing agents, A2 plus, B2 plus, C2 plus, and D2 plus. Okay. NO3 minus is a spectator ion. All right. Metal A will not react with any of these solutions. Metal A is a reducing agent. It does not react with any, which means it's the weakest oxidizing agent sitting up at the top. So we got A2 plus 2 electrons goes to A. Okay, so that one's easy. Does not react with any. Okay. C2 plus reacts with B. All right. So I'm not sure where this goes yet. I just know C2 plus is above B. B will not react with D2 plus. B does not react with, okay, so that means D2 plus has to be down here below the B, right? B does not react with D2 plus. So D2 plus is below B, but C2 plus does react spontaneously with B. Okay, and there we go. So C2 plus 2 electrons gives C. B2 plus 2 electrons gives B, and D2 plus 2 electrons gives D. And there's another snapshot of my middle school report card. I really like to spread it out: an A, a B, a C, and a D. Weakest oxidizing agent and strongest reducing agent is D. That means D reacts with everything, and D plus reacts with nothing on our table of relative strengths. Okay, wow. I am ecstatic to be done those examples. So to practice this, practice questions 12 to 22, skip 13 and 21 on page 573. A second one you could do is solutions for extra exercise, creating a table of extra exercises in your study guide. I have posted the answers on Google Classroom for that. And when I see you tomorrow, we will be doing the 5-step. And I know that sounds like it's a dance move, but it's actually not quite as exciting. So it's another way to balance redox reactions. We have mastered the half reaction method, and that's number 1. And then tomorrow we learn number 2, and then you can balance redox reactions with 2 different strategies. Okay, that's it. Have a good evening, good afternoon. It's late evening for me, and I'll talk to you next day. Bye.